Hello, I'm here today to help you with the following problem. Convert the surface 4y squared plus z squared minus x minus 16y minus 4z plus 20 is equal to 0 to standard form. Classify the surface and graph it. Okay, so to tackle this problem, what we first want to do is we want to put like terms together in our equation. So let's start that off with y. So if we have 4y squared, then we have minus 16y, and then we have plus z squared minus 4z, and here we have minus x is equal to negative 20. Let's just subtract it to the other side. Okay, so the next step we want to do is we want to complete the squares here. We want to complete the squares so we can have this looking in standard notation. Okay, so we're going to complete the square here, but instead of having to complete the square of 16, how about let's factor out a 4, and let's complete the square of negative 4. So to complete the square, what we do is we take this value, we divide it by 2, and we square that value. And then we add it and subtract it. So let's do it. So we divide 4 by 2, or negative 4 by 2. That's negative 2. You square that, positive 4. Positive 4. However, there is a 4 being multiplied to it. So this is to cancel this out, we would have to write minus 16 here. And instead of doing that, how about let's just add it to the other side, and we'll write it down with the negative 20 once we complete the square for the z. So let's work on z. So we have plus z squared minus 4z. So we once again have negative 4, so we divide it by 2, which is negative 2, and then we square that, which would be positive 4. And now we have to subtract 4, or we add it to the other side. And we have minus x, and here we have minus 20, and here we have plus 20 from the values we got from computing the square, which that'll just be 0, which is good. So now we want to factor these out. This is why we decided to complete the square, so we can have a nice factorization. So here we get 4y minus 2 squared, right? Because if we factor this out, if we do y minus 2, we have 2 times 2 is 4, and then negative 2y minus 2y would be minus 4y, and then we have y would be y squared. So here we have, and now same thing for z, right? They're the same, they have the same values to each other, so we have z minus 2 squared is equal to x. Okay, and this would be this equation in standard form. So we need to classify this surface, and we know it to be an ellipsoid paraboloid. Now, how do we know this, right? Let me just write down what type of graph it is, and I'll explain how we know. Okay, so the reason why we know that this is an ellipsoid parabolic is because we should know the general equations of 3D surfaces. We should know their general form. So the general form for an ellipsoid parabolic is z is equal to x squared plus y squared. This is the general equation for an ellipsoid parabolic, and we do have a y squared. And in this case, instead of x, it would be z. We just flip the 2 around. We have plus we have the z squared, and we have the y squared, which would be d. And this will be, this is how we know that this would be an ellipsoid parabolic. It has the same formation or the same setup as a general equation for the parabolic, the ellipsoid parabolic. So this is how we know that this is an ellipsoid parabolic. Now it asks to graph, and unfortunately for everyone, graphing just does not happen to be my strong suit, but I will indeed try. However, 3D graphing can be a little messy, but let's do it. Okay, so this is my Z, X, and my Y. Let's see this. This would be 2, this would be 4. This would be 2. And then let's 2, 4, 6. Okay. So to graph this, you'll want to. Okay, so you know that it'll be okay. So the graph is gonna end up looking like this. Pardon the very poor looking graph, but it's gonna end up looking like this. Okay. And that is how you solve this problem. So, thank you for watching.